So good morning to all. So in the last class, we discussed about some of the functionalities of your process. So now we are going to discuss about interrupt handling. So what do you mean by interrupts? So basically, if you talk about the interrupts, so interrupts is going to basically inform the processor that an external device or an associated task requires an immediate attention. That means whenever the interrupt coming from the outside, so that particular interrupt has to be served first. Okay, so that has to be given the priority. So when you talk about the interrupts, we are going to have two different types of interrupts. One is maskable and the other is unmaskable. Okay, so now if you take your processor in the OS, so the OS can handle multiple interrupts. Okay, so now when you talk about the interrupts, so interrupts can be either two types. What are they? One is synchronous, other is asynchronous. Okay, so now whenever you are going to have the interrupts which occurs in synchronous with the currently executing task, so that is called as synchronous interrupt. So that particular interrupt is going to occur with respect to the currently executing task. So example for that particular type of interrupts is a software interrupt. Okay, so when you talk about the synchronous interrupts, so now the interrupt handler which you are going to have, that particular handler is going to run in the same context of the interrupt running task. Okay, so that is what the main thing which you are going to have in your synchronous interrupts, so that it is going to run in the same context of the interrupting task. So the next type is in asynchronous interrupts. So in this type of interrupts, so this particular type of interrupt occurs at any point of the execution of any task. That means whenever some task is running, so at any point of the time in between of the execution of that particular task, the interrupt may come. So and they are not in sync. So they are not in sync with the currently executing task. So that means it is not synchronous with the currently executing task. That means whenever the external interrupt is generated by the hardware, for example, so that particular type of interrupts you are going to have through the will be your asynchronous interrupt. So normally that particular type of interrupts which will be generated by the external devices. Okay, so those type of interrupts are nothing but the asynchronous interrupt. So now when you're talking about your asynchronous interrupts, so asynchronous interrupts in this particular type of interrupt, the interrupt handler is usually written as a separate task. Okay, so the interrupt handler which you're going to have, so that particular interrupt handler is going to return in separate task. So if it is written in a separate task, what it means? So since it depends upon the OS kernel implementation, so this type of interrupt handler which are going to return as a separate task, that will depend upon the OS kernel and implementation. And this particular type of interrupts, so whenever you are going to write that particular in the separate context or separate task, so that will be running in a different context. Okay, that will be running in a different context. So that's what it is going to run in your asynchronous interrupt. That means, so in your asynchronous interrupt, what will happen? So the interrupt may come at any point of time in the of the currently program execution. So it will be having the high priority at that time, and they are not in sync with the currently executing task. So that's what your interrupt handling is going to specify. So the next type of is this one is time management. So in this particular time management, so it is going to essentially for providing the precise time references. Okay, so when you are going to have the process running, okay, so whenever the process is running, so now how much time that particular process is taking. So that means how much time that particular process takes. A process takes, okay, or so that asks how much time a task takes. So it should have some defined some precise timing should be there for that particular application to complete its execution. So it is this particular management is going to essentially provides that particular type of functionality. Okay, so now so this particular time reference for your kernel. So when you are defining the OS, so we are going to speak about the kernel only. So the time reference to kernel is going basically it is going to be provided by what? It is going to be provided by your real-time clock hardware chip, which will be there inside your processor. Okay, so you are going to have the real-time clock hardware chip, which will be there inside the processor. So that particular timer will be there inside your processor. Okay, inside your board. So that is going to take care of your timing management. Okay, so that is hardware. That particular type of timer is referred as hardware timer. So here it is outside your OS. So that will be dependent on your hardware, which you are going to have. So since it is going to have the microprocessor involved in your operating system, so it is going to have the outside. It will be not inside the single chip. So it won't be not inside the chip. But if it is a microcontroller, it will be inside a single chip. So if it is a uh, normal OS, so if, it will be outside the processor. So now here, if we talk about the hardware timer. So if you take the hardware timer, so that particular timer is programmed to interrupt the processor. Okay. So whatever the timer it is going to have, so that particular timer is going to interrupt with respect to the processor. So that particular interrupt which you're going to have programmed, so that will be controlled at a fixed rate. So that will be controlled at the fixed rate. Okay. So the timer interrupt here, so the whatever the timer interrupt you are going to have in this one, so the particular timer interrupt is basically referred as timer tick. So that is basically referred as a timer tick. So now what do you mean by timer tick is the next step. So we are going to refer that one as timer tick. So next comes the question, what do you mean by timer tick? So now your timer tick is taken as what? So timing reference by the kernel. So it is going to have the reference. Okay, so that is important point. So it is going to have the reference. So the timer tick is going to taken as a timing reference by the kernel. So now when you talk about the timer tick, so the timer interval which you are going to have, so that the period between the hardware timer, so which you are going to have. So the timer interval when you are running for the different applications, it may vary. It may vary depending upon your hardware timer. So the timer tick is going to interval may vary depending upon your hardware timer, because totally the timer depends upon your hardware. Okay. So when you are going to run that particular hardware, so here since it is depends upon your hardware, so it finally it also depends upon your processor speed also. So processor speed, how the different what is the width of the bus, so even that one will matter here. Width of the bus is also matter here. So now that's what it is going to tell that. So depends upon the different types of hardware which you are going to use, so your timer tick is going to vary. So your timer tick, as it is varying, the interval between your timer tick also depends, it will be varying depending upon your timer hardware timer. Okay. So always when you are going to have the variations with respect to the timer tick, so it will be varied in terms of microseconds range. Okay. So usually the timer tick which you are going to have, that will be varying in terms of microseconds range. Okay. So next, when it comes to that, so here, the timer management for task, which you are going to have. If you take the time management, the same thing. So there are some parameters which you have to take. So when you are telling that it is going to vary in terms of nanoseconds, right? So nanoseconds, it is going to vary. Okay. So vary in terms of nanoseconds. So if you take the parameters, okay, if you take the parameters for task, which are expressed as the multiples of the timer tick. So that means if you take one single task, so that particular task will be of n number of timers. Okay, so that will be task having the n number of timer. So that will be expressed in terms of multiples of timer tick, because each timer tick is each timer will be running at each instance of time. So now whatever the system time you are going to have in your system, so it will display the system, right? In the system you are going to have if you take the normal PC, so we are going to have the system time, right? So the system time is basically updated using your timer stick. So you are going to have the timer, right? So you are going to have the clock. So clock is there and it will show you the date and time, right? So date and time in your system. So basically if you take how it is going to show this particular date and time. So this particular date and time in your system is going to be updated depending upon the timer tick which you are going to have. So it will be controlled by your time management. So it will be controlled by your time management. So now if you take your system, so okay, so if the system time register is 30 bits wide, okay, so if the system time register is 32 bit wide and the timer tick interval is 1 microsecond. So now for how many times it is going to reset, the system register will reset for, since it is 32 bit wide, so it will be varying from 2 power 32 into microseconds, that is 10 raised to minus 6 divided by number of hours into number of seconds into number of minutes, number of minutes into number of seconds. Okay, so that will provide you the 1.19 hours. So that will come as 1.19 hours. So since the registers which you are going to have this particular system time register, so that is of 32-bit. So that 32-bit means the maximum time which will be having maximum value which can afford that particular size is 2 power 32. And so what is the interval it is going to run? So that will be running in 1 microsecond. So that will be 10 raised to minus 6. So now for how much, what is that date? What is that time you're going to have in each day? So you're going to have, so 24 hours, 60 minutes and 60 seconds. So that will convert in terms of seconds. So this is the number of seconds, your number of seconds in a day. Okay, number of seconds in a day which you are going to have. So when you are going to have this particular part, so it is going to tell that, so your system time register is going to reset for every, so system time register. Okay, so system time register is going to reset for every 1.19 hours. So now for example, so if you take this one, 32 bits wide and the timer tick interval is 1 millisecond. Okay, so timer tick is 1 millisecond. So for how many days it is going to reset is the next question. So if we take the same example, so it is going to have the 30 bits wide, so it will be 232 power 32, and it will be timer tick interval. The interval between the timer is 1 millisecond, so it will be 10 raised to minus 3. So divided by number of seconds per day, that is 24 hours, 60 minutes and 60 seconds. So that will be number of seconds your timer will be running for a particular day. So that will be given by 50 days. Okay, that will be given by 50 days which you are going to have. So where your system time register will reset. So if the timer tick is 1 millisecond. Similarly, if it is consuming that, if for example, if we take the timer tick interval is 1 nanosecond. So if you take the timer tick interval is 1 nanosecond, is 1 nanosecond, and if the system time register, so if you take any time, so that particular system will be having some system time register. Okay, so system time register will be there. So the system time register which you are going to have, so that is given by 32-bit wide. Okay, so then if it is 1 nanosecond, what is the change I have to do? So it will be 2 power 32 into 10 raised to minus 9 divided by 24 into 60 into 60. So this you have to do some amount of days it is going to come. So for that many hours, so you are going to have the system reset. So the system time register will reset for certain duration of time. So you just calculate it. It will be given as an assignment for you. Okay. So similarly, the time management. So here, whenever you are going to have the timer tick. Okay. So the timer tick which you are going to have. So that timer tick interrupt can be utilized for implementing the following actions. What are the different actions your timer tick is going to do, or your timer tick is going to utilize? So utilizing the timer tick. So utilizing the timer tick which you are going to have. So what are the different actions it is going to have? So first, whenever the whenever the interrupt comes, for example, first you have to say the current context. That means the task which is running, that has to be stopped, right? So when they are going to have the different timer intervals between the applications, so it is nothing but what, so you're going to have two tasks. So when you want to shift that, so between, if I'm going to give that 1 nanosecond is a timer interval between these two tasks, so that means for every 1 nanoseconds it will be alternately running if it is round robin. Okay, if it is a round robin scheduling. So now what will happen at the time? So whenever the timer tick, okay, so when a timer tick is issued for 1 nanoseconds, depending upon the scheduling what you are going to use, so that particular task has to be given the time. So when you are going to give the time, what are the action it has to take place? Okay, what are the actions has to be implemented? So now what they have to do? So whatever the task I am running presently, that has to be saved first. Save the current context of the task. So whichever the task is running currently, so at what point of time the interrupt has been sent or the timer tick has been arrived. Okay, so for that particular instance of time, so that particular part of the current running task has to be saved. So you have to save the current task. So at what point of time that particular job is being stopped. So then what I need to do, then I have to update the timers implemented in the kernel. So that I have to start the kernel. Okay, I have to update the timer. So for what, for how much time this particular task has to run. So as I told you that you are going to have two tasks. I'm going to give 1 nanoseconds, 1 nanoseconds, for example, to run. So once this particular timer has been implemented, it has to start running it. Okay. Once again, starting from 0 to 1 nanosecond, it has to run this particular process. If it are a task or process, if you are going to have. So now when it is running, when it reaches 1 nanoseconds, so whatever the process is already running or the task which is already running, so now again it has to save this particular task. Okay, it has to save the current context and it has to release to this particular process. Again, the timer of this particular task starts running. So after 1 nanoseconds, so it has to release it and it has to give this one till this particular task is completed. Okay, this particular task is completed. So that depends upon your timer tick which you are going to use. So for every time which you are going to have to shift, so you have to update the timers. So basically timers which you are going to have, the timers will be implemented inside the kernel. Okay, the timers will be inside the kernel. So first, when you are going to implement it inside the kernel, so what I need to do first? So if I'm going to implement that particular timer takes inside your kernel, first I need to activate the periodic task. So that means, so for any task to be done, when it has to be done, some time duration will be there, right? Some time duration will be there. Some time duration. For example, I think so 20 milliseconds is required for one process to complete, for example. So now whatever the periodic tasks are there, so this particular task is requires 20 milliseconds. So I presently, presently this particular task is not running, so it will be in idle state. So presently this particular task is not running, which will be in idle state. So whatever the process or the task which are in the idle state, that particular task has to be activated first. So before the timer starts, first I need to activate that particular periodic task which are in the idle state. So now after activating the periodic task, what I need to invoke, so because I don't know that what type of algorithm I am using for that particular task. So some algorithm, some process may be using first come first serve algorithm, or some process may be using round robin algorithm. Some process may be using your schedule priority based algorithm. So I don't know what type of algorithm that particular process is using. Now who has to decide that one? That has to be decided by your scheduler. So to have that one, we have to first, what we have to do, we have to invoke the scheduler first. Okay. Next, I have to invoke the scheduler for that particular task, and I have to schedule the task again. Okay. I have to schedule the task again based on the scheduling algorithm. So depending upon the scheduling algorithm, you have to schedule the task. So who has to do that one? So that has to be done by your scheduler, which will be there. Okay. So once you have scheduled that particular algorithm, so assume that some of the task has been completed its execution. Okay. So that means that whatever the process it will be running, so that will be stored in the data structure. So that will be stored in the data structure TCB. So then whatever the completed task is there. Okay. So when you are going to have, so the completed task which you are going to have, so that has to be terminated. So you have to delete all the terminated tasks, and what are the data structures which it is associated with. So as I told you that each TCB is having the data structure which are linked together because it is having some size constraint. So depending upon that one, it is going to be assigned. Okay. So that will be done using you in the time management depending upon that one. So at the last, when you are going to have, when your particular task is completed, so what we have to do, so we have to delete all the terminated task, and after deleting all the terminated task and related to that particular task, what are the associated data structures which you are using. So even that one I have to terminate it. Okay. So that we have to do. So that will be taken care by your time management of the process which you are going to have. So now after that one, so we come to your normal real-time operating system. Okay. So anybody having any doubt here till now? Anybody having any doubt? Functionality of your OS. Okay. So the next, when it comes to real-time operating system. So basically, if we talk about the real-time operating system, so there are two types of real-time operating system which you are going to have. One is your hard real-time operating system. So second is your soft real-time operating system. Okay. hard real-time and soft real-time. So next, when it comes to the hard real-time operating system, what do you mean by hard real-time operating system? So in this particular type of real-time operating system, it has to strictly adhere to the deadline. Okay, it has to strictly adhere to the deadline. So deadline is in the sense means what? So it should have the timing constants per task. So that is nothing but it is should strictly adhere to the deadline. So deadline is nothing but what? So that particular timing is given for that particular task to be completed. Within that particular timing, that particular process has to complete its execution. Okay, so that's what the hard real-time operating system is going to tell about. So now, when you are going to discuss with your hard real-time operating system, so we are going to tell you that it must meet the deadlines. Okay, it must meet the deadline for task without and slippage. So that means without stopping. So without slippage is nothing but what? Without stopping or interrupting. Okay, so without stopping or interrupting. So that particular task has to complete its execution within the given period of time. Now, if it is not able to meet the deadline, what will happen is the next question. Okay, so now if we are missing the deadline, so that particular uh, what it is going to produce is that may produce you the catastrophic results. Okay, so it is going to if you miss the deadline, it is going to produce the catastrophic result. So this particular catastrophic results, so what it includes, so it includes the permanent data loss. So that includes the permanent data loss and irrecoverable damages which are going to have the system or the system or user. So now most of the times, what will happen? So your hard real-time system, if you take, so they are automatic. So if you take the hard real-time system, they will be designed for automatic fashion. So hard real-time, for example, is your the operating system which you are going to use in your airbag is the best example what we can take. So which you are going to have the airbag or automatic braking system, ABS, anti-lock braking system, which you are going to have. Okay, so here the airbag in the airbag control in the airbag, what will happen as soon as your car is encountered with an accident, what has to open? So the airbag has to open. So now if it misses that particular deadline, what will happen? Something is going to happen for the driver who is going to be sitting in the front. Okay, so if the impact pressure is more, so now so it should not meet the deadline at that time. So it should automatically be done, right? So as soon as your car it's met with an accident, so depending upon the type of the pressure at which the accident has occurred, so your airbag has to open. So now if it is not opening within this particular period of time, so you're going to have the catastrophic result. So that means you're going to have the irrecoverable damages. That means the driver who is going to be sit in the front seat, or the person who is going to sit in the front may die, or say may lose his leg or hand. Okay, so some catastrophic result is going to be happen. So that means is going to have the great damage. So the great damage is going to happen. So if that particular deadline within that particular period of time, so that particular event is not created. So now when you talk about the hard real-time system, so it is automatic and does not contain a human in a loop. So that means what it is going to have. It is not containing human in a loop means what? No intervention of human being there. So it will be not having the intervention of human being. So no intervention of human being will be there. Okay. So that's what you are going to have. So it basically emphasizes on the principle. Let answer is a long answer. That means what? So if that particular system response is late, then the result will be catastrophic. So that means that result what you are going to get is unfortunate or extra unfortunate results you are going to have. So it is going to cause you the sudden damage. Okay, so causing the sudden great damage you are going to have, or more sufferings is going to have. So the example in this type of systems are your, as I told you that it is airbag control system and anti-lock braking system, that is ABS, as a vehicle. So now if we talk about as a rule of term. Okay, so your art real-time system, if you take, it does not implement the virtual memory model of the handling the memory. So that means it will be not having the virtual memory model. So if you talk about the virtual memory, all of you have gone through the virtual memory, I think. So it does not implement the virtual memory model. Okay. So next comes the question. So now, so this particular virtual memory is nothing but what? It is nothing but the physical memory which is installed on the system. So it is going to have the physical system. So your virtual memory is nothing but what? It is nothing but the physical memory which will be installed in the system. So as a rule of thumb, what it tells? So as a rule of thumb, it will tell that so your all real-time systems will not implement the virtual memory model. Will not implement the virtual memory model for handling the memory. That means, so that particular memory you are going to have, so that particular extra memory which you are going to use, that won't be installed in your physical memory or physical system which you are going to have. So there extra memory which you are going to use for your program to execute, so is called as virtual memory. So and this part of the virtual memory always reside inside the secondary memory. So that you have to keep in mind. So always the virtual memory will be in secondary memory. So that is in your hard disk. Okay, this particular virtual memory will be in hard disk. So that how it is going to emulate that one? So that's set up to emulate the computer's RAM. So both your contents in your RAM, okay, so contents in your RAM as well as your virtual memory will run in tandem. So this virtual memory, this is the data which is running, which is there in the RAM. So virtual memory is inside in your hard disk or in your secondary storage. So when you are going to, when your RAM is not able to afford all the instructions which has to be executed, some part of the execution will take place in your virtual memory. So this particular virtual memory where the task is where the memory is used for running. So this will be stored in your secondary memory. So now what it does, so if you have the virtual memory, what is the advantage is the next question. So we have gone through the virtual memory. So next comes the question, what is the advantage of using the virtual memory? So if you are using the virtual memory, this eliminates the delay in swapping. Okay, so whenever you are going to make use of the memory and if you want to execute, so you are going to do this swapping with respect to the memory address or the requirements for the process to run, right? So that is nothing but what, so I want some process is running. So when you want to execute some other application, what I need to do, whatever the data is there in your RAM, I have to remove that particular uh, code from the RAM and I have to insert the code from the secondary memory so that I have to swap it. So now what it will happen if you are using your virtual memory, so it is running in tandem. So if you are running in tandem, what it is going to have, it is going to eliminate the delay in swapping. So it is going to eliminate the delay in swapping in and out of the code corresponding to task 2 and from the primary memory. So that means it is going to delay in swapping. Okay, so that is one advantage which you are going to have when you are making use of the, when you're not implementing your virtual memory. So if you are using virtual memory, these are some of the problems which you are going to have. So if you are not using the virtual memory, so it will eliminate the delay in swapping in and out of the corresponding to task to and from the primary memory. Okay, so next when it comes to the same thing, so the next is the same, the soft real-time system. So when it comes to soft real-time systems which you are going to have, okay, so it is type of a real-time system that does not guarantee meeting deadlines. So in the soft real-time systems, what will happen? So this type of RTOS, okay, so this type of RTOS, what you are going to have, it does not guarantee meeting the deadlines. Okay, so even then, if it is not meeting the deadline, nothing catastrophic result is going to happen or nothing but, so it's a sudden damage is not going to happen. So it's sudden damage not happening. Okay, so sudden damage not happening here. So even it is not meeting the deadline. So but it will offer the best effort to meet the deadline. So it will make its best effort to meet the deadline even if the deadline is not met. Okay, so no harmful thing is going to happen or no sudden damage is going to happen in for that particular task which will be running. So now in this type of soft real-time systems which you are going to have, So missing the deadline for task are acceptable. Even if you miss deadlines for that particular task, they are acceptable. Okay. So if the frequency of deadline missing is the compliance limit of the quality of service. So that what it means is the frequency of deadline missing. So whatever the limit you are going to set, okay, so limit you have said that, so that particular task has to complete in 10 millisecond. Okay, some external event is going to occur. So whenever the external event is occurring, so depending upon the external event, your real-time operating system has to respond, right? So that particular response has to respond within the limit. Okay, so within the limit means what? So my limit is 10 milliseconds, what I have given. Within this particular period of time, that particular task has to be completed. So then if it is not complete, then if it is completing within the compliance limit of time, so that particular type of software time system, what it is going to provide, so it is going to give you the proper quality of services. Okay, proper quality of service it is going to give. So if that particular event is going to complete within the compliance limit what it has been set for that particular task to run. Okay, so now, so basically if you talk about the normal definition, so it is emphasized on the principle. So a late answer is an acceptable answer, but it could not have, but it could have done bit better. So what it going to tell? So it emphasizes on the principle that even you can respond late. Okay. So, but you would have done it better. So whatever the task has been given, so that particular task has been if it is completing its job within the way, if it is not completing its job within the deadline, it is not it is acceptable. But you have to keep in your mind that you have to complete it fast. So that has to be keep in mind. So now when you are going to have the soft real-time systems, if you are going to have, okay, so it is basically it is going to have the human in the loop. So this type of real-time systems which will be having, so that will be human intervention has to be there. Okay, so human intervention should be there in this particular type of real-time operating system. Okay, so your human intervention should be there. So example for your soft real-time operating system is your ATM, which you are using your day-to-day life. So to remove the money, you are going to make use of ATM. So this is one of the example which you are going to have. And in the car, which are going to have the audio video playback system. So in the normal car, we are going to have the playback system, right? So in that particular playback systems, you are going to have the audio video, so to be running. So to run that particular audio video, you should have some playback system. So that is one typical example for your software science system. So even if when you switch on your audio, if the audio is not running within that particular period of time, and if there is some delay in starting of your audio to be started, so then no harmful or no catastrophic results or no sudden damage is going to happen for your system, right? So even if you tap your automated teller machine, so you in that particular automatic teller machine also, so if the machine is giving your money a little bit late, so then you can wait for that one. So then is no harmful damage is going to happen for that one. So if that particular ATM machine is not dispatching the amount itself, means then it's a problem. So if it is dispatching, and if that particular money which it is dispatching is taking little bit more time to dispatch it, then no harmful is going to happen. So that's what the difference between your hard real-time system and software real-time system. So basically is, if you're talking about the hard real-time, you should adhere to the deadline. So whereas your soft real-time, so even the deadline is not met, so no harmful things or events are going to happen. No harmful events are going to happen for that one. Okay, those are the difference between your uh, soft real-time system and hard real-time system. So after going through soft real-time system and hard real-time system, so the next part which we have to discuss is about your task processing threads. Okay, so anybody having any doubt in your soft real-time system, soft real-time operating system and hard real-time operating system? Anybody having any doubt? Anybody having any doubt? Okay. So now the next topic which we have to discuss is your task, process, and threads. Okay. So now when you talk about the operating system, so just I will brief it out in today's class. Okay. So if you start talking about the process, so as you already studied your operating system, what do you mean by a process or a task is defined as a program in execution. So you're going to have the program, so that particular program is in execution. So a task is defined as the program in execution. So what when it is executing, what your operating system has to maintain. So the related information about that particular process has to be maintained by the operating system for the program. Okay, so whatever the information required for that particular process to run, so that particular information has to be maintained by whom? Has to be maintained by the operating system. Okay, so next if we talk about the task, so normally a task is normally also, it is also known as a job. So other name which you are going to give for a task is also job. Okay, so other name which you are going to have a program or a part of it in execution. So a program or part of it in execution is also referred as what? Is also referred as the process. So that is another name. So if we talk about the in the terms of your operating system concept, so your task, job, process all relate to the same. So but they are referred with different names. Okay, so all refer to what? A program in execution. All refer to a program in execution. So if you take the task also, it's the definition for your task also, a program in execution. A job is also referred as a task. A process is nothing but, the other name is also is nothing but what? A part of the task is in execution. So if you talk with respect to the operating system concept, so all these terms relate to the same thing, which is nothing but your a program in execution. So that's what your task, job, and process refers to the same entity in the operating system concept. So and most of the times they will be used interchangeably. So depending upon that where you are going to use that particular word, so depending upon the context where it has been used, so that particular word will be taken. So and they will be used interchangeably. So what are they? It's nothing but task, job, and process. So now when any system process has to run, what it requires is the next question. So if I have to run the process, right? So if I want to run the process, so what it requires? So it requires various system resources, right? So if I want to run the application, what do you require? So first I should have CPU. Okay, so then even if the CPU is there enough, so if it has to run speed, I should have RAM. Okay, so then I have to store the code. If I want to store the code, some memory should be there, secondary memory should be there, right? So then, so I have to, whether you are going to run the code directly, I have to give the instructions to the input unit, and it has to be displayed, the output, the result has to be displayed to the output. So then I should have some IO device for information exchange. Okay, so these are some of the resources which is required, okay, for executing the process. So like say CPU for executing the process, memory for storing the code corresponding to the process, and it should also require the memory to store the associated variables. So whatever the variable you are going to have, so that is nothing but what? So as we have already discussed, that variable is nothing but named memory location. So when you are going to have memory location, it means what? I should have some storage space to hold that one. Okay, so then you should have some uh, interactions you are going to take place with the outside world, and you are going to give the input through the input unit. So for to do that particular data exchange, you should have some IO devices. So these IO devices you are going to make it used for your information exchange. Okay, so this is what the basics of your process is. So I will stop here now. So in the next class, I will start with the structure of the process. Okay, so anybody having any doubt, you can ask. So if you have any doubt, you can ask.